Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to do the last concept in electrochemistry. We're going to do electric work. But before we do that, I've got a problem over here on my right, your left. So pause the video, work through this just to see if we've got this understood. We're going to answer any questions. Any questions, let me know. ltswpd@gmail.com. Remember, like, subscribe, share out. Here we go. Pause. And the answers, here we go. So the final answer is 0.891 volts. It's at standard, so we're using 0.0592 volts over the number of moles, which in this case will be 6. All right, hopefully not too bad. All right, last concept we'll look at here in electrochemistry, and that is called electric work. Electric work is the amount of electrical energy needed to perform a given amount of work for a specific amount of time. Now, when we do work is always identified as a delta G, and delta G we said is NFG, negative NFG. To find work exerted, we're going to take the positive of that. And a unit of work is watts. Watt is unit of energy. Yes, that's true. And a watt is a joule per second. There's another value you also need to know, and that's a kilowatt hour. Kilowatt hour is 3.6 times 10 to the 6 joules. And then the last thing we need to understand is for every electron we have there, we have Faraday's constant, it's 96,500 coulombs. All right, copy all those down. Here we go. Let's look at a problem. Calculate the amount of energy needed in kilowatt hours to electroplate 3.555 kilograms of copper if 3.333 volts of electricity is applied. So again, those are all the values that we need. The relationship of electrons and coulombs. That a coulomb volt is a joule, the number of joules in a kilowatt hour, and we're using 2 electrons for copper. All right, so let's start with the amount of copper. We need that in grams, so we're going to go from kilograms to grams. 1,000 grams is a kilogram. Now, once we have that, we're going to convert that to moles. So 63.5, remember copper and chlorine are 0.5, is 1 mole of copper. And then for every 1 mole of copper from over here, we have 2 electrons. And then Faraday constant, 96,500 coulomb is 1 electron. Multiply that by the voltage used. So take 3.555 times 1,000 times 2 times 96,500 times 3.333. Equal, divide by 6.3, 63.5 rather, equal, and we get, and I got to convert from kilowatt to joules, and we get 3.601 times 10 to the 7th joules. That's a huge number. Now we want this in kilowatt hours, so we put that over 1, and 1 kilowatt hour is 3.6 times 10 to the 6 joules, so take 3.601, EE minus 7, divide by 3.6, EE 6, equal, and we get 4 sig figs, because 4 sig figs right here, and 4 sig figs right here. All right, and we get 10.00 kilowatt hours. All right, that's the first bit of work we've done. Second problem we look at, determine the amount of energy produced in joules in a voltage cell of a silver lithium if 36.75 grams of silver plate out in 4 hours. Now we're going to just simply find the E prime. We're not going to worry about the conditions because I need concentration, and then also report it in watts. All right, so we have over here that a watt is a joule per second. So what we're going to do is we're going to take our reactions. Silver, that's my cathode. Lithium is my anode. So we subtract them and we get 3.724 volts. Okay, take our silver, convert it to moles again. And for silver, because it's 1 mole, 1 electron, and then Faraday constant, multiplied by the voltage we just said, 3.724 volts. And then a coulomb volt is a joule. Take 36.75 times 96,500 times 3.724 equal, divide by 108 equal, and we get 1.223 times 10 to the 5th joules. Now, remember we said that we have 4 hours. Now that's an exact number, so we just simply have limited to 3 sig figs there. So we're going to take and divide those because it's a joule per second. So we take our joules, divide by seconds. So take 1.223 EE5, divide by 1.44 EE4. Now we're going to have 4 sig figs here because this is infinitely significant. So the answer is 8.493 watts. All right, hopefully not too bad. Okay, now I've got 2 problems for you. The first one, there's the number of electrons, and there's the second one. Pause the video, work through this. I'm just going to give the answers. I'm not going to show the work. All right? All right, here we go. First one, answer is 46.72 kilowatt hours, and the second one is 22.7 watts. All right, hopefully not too bad. Take care. God bless. Bye.